Alright, in this video we're going to look at lab 8 and 9. So we'll be looking at lab 08 and lab 09, which were basically just programming practice. So first, a demo of what's supposed to happen and maybe a look at the code. These are past due to give some people some help. Okay, so let's look at lab 08 first. Alright, so these were both from practice programming assessments in this question with just basic loops. And the first one here is adding up the numbers 1 to 37. There's no input, there's no scanf. It doesn't do anything with arg, the command line arguments. And I did give you correct working version of that. 1, 1. All it does is print out the result, which is adding up the sums of the squares of the odd numbers from 1 to 37. That is just a for loop. And so this is the for loop. Alright, so you have a sum. It starts at 0. You need to initialize your variables, especially things like a sum. So starting from 1, less or equal to 37, go up by 2. I'm going to add on I times I. That's it. If you want to pause the screen to see that solution, that's fine. Go ahead and pause it. Alright, next question. We have, let's see, from sample number 2, programming assessment sample number 2. This is another one with just a basic for loop. No input, nothing with command line arguments, just a straight loop. So this is asking, this is a little bit more interesting, asking for upper and lowercase letters together with their ASCII values. And since you have a correct working version, you should use it. Let's see, this is supposed to be called, okay, Practice Assessment 2, number 1. Okay, so you can see here, there's the lowercase letters, and those start with ASCII value number 97. And you have the uppercase values. Those start with ASCII number 65. Alright, to start off with, in your program, if you had trouble with this, you want to print just the first line. So how do you print the letter A, and what is the ASCII value of A? So for this line, how would you do it? A useful way to do it would be like this. There you have the letter A in a variable, and you could do printf %C %C CH. So that is what you need to start with. If you can't get the first line, you're not going to get the whole output. This is the character A, and this is the integer, the ASCII value for that. Okay? You have to get that to work first. Put it in your program. You have to get it to work. Then the next thing to do would be all of the lowercase letters. That's going to be from A up to Z. So the way I would do that would be CH equals A, CH is less than or equal to Z, because they are in order, CH plus plus, and then inside of my loop, C above. I have my value of CH is going from A up to Z, and then I would just put this print statement in. Okay, so then you want to get that to work. Test it, run it, make sure it works. You want to add on the uppercase letters, you have another for loop. from uppercase A while it is less than uppercase Z, CH++, and then you'd have the same thing inside with this print. So 2 loops will do it. The spacing here, there's an extra space. So to do that, I believe %3D will do it. You can look up the help on printf, but that says that the integer is supposed to take up 3 spaces in the output. It'll give a space there if it doesn't take up 3 spaces. Alright, if you want to pause the screen, you can. We'll move on to the next one. Alright, these were the bit ones. The number 5 questions on the practice assessments. So lab0815, if I run it, it asks for an integer in hex. I'll give it the one it gives as an example. And what it does is it reverses the bytes. So each hex character here, each hex digit is 4 bits. 2 hex digits is 1 byte, is 8 bits. So if I'm going to switch, this is 1 byte, and I want to switch it with the first one, so the 3, 4 goes into the 1, 2. Let's try another example. So what if I type E2 F1? Okay, what should it be if the bytes are switched? The F1, that's the last byte, goes in front. The E2 goes in back. Okay, we go back to the, if we look at the problem statement, this was number 5 on this. It says to have a function named reverse that takes an unsigned short integer as a parameter and then will return an unsigned short. So in your code, you should do that. So in my code, I have an unsigned short function named reverse, and it takes an unsigned short int num as a parameter. And so what you need to do is you need to be able to, let's go back here, so we need to be able to pull out both bytes, the last byte and the second byte. And there's a lot of ways to do that. Here's one. So this would be the first byte. I take a 16-bit number, I shift it to the right by 8 bits. Then that would be if I shift this, so shift this value to the right by 8 bits. These are 8 bits, those fall off the side. So if I do this, shifted right by 8, then I would get this. So the E2 goes to the right, the F1 falls off. Okay, so that's the first byte that gets shifted over. And then if we look inside of here, this is the second byte. So num and FF, if we go back over here and we say, okay, 0x E2 F1, if we do and 0x FF, that is 0x F1. So we're only anding with these last bits here. And then we shift that left by 8 bits. So if I then shift that by 8, then I have 0x F1 0 0. And then this value here, or them together, that's what we want. Okay, if you want to pause the screen to see the code for that, go ahead. Moving on to the next question, which was the bit question on the second sample exam. Okay, let's run this one to see how it's supposed to run. This is asking for an integer in hex. We'll give the one they give there, and give an integer from 0 to 31 in base 10. I'll give the integer 4. Okay, so what this one does is it's a left shift by this many bits. If I say 0x1234 and I shift by 1 bit, it's not as easy to see exactly what it's going to do. You have to put this into binary. So in binary, this would be 1 is 0001, 2 is 0010, put a space in between them, 3 is 0011, and 4 is 0100. So that's what this hex number is in binary. If I shift that by 1, then I put an extra 0 here on the end. So then all of these would be shifted in terms of where the cutoffs will be for the 4 bits. So here we would have, that's 8, that's correct. So there's 6, and we see the 6 over here, 4, and the 2. So it's just shifting the binary by 1. If you do multiples of 4, then it's easy to see because that shifts over by hex digits. 4 bits is 1 hex digit. So 1, 2, 3, 4, 5, 6, we get two hex digits, 1 byte worth of zeros there. Alright, this is the interesting part of this is if we have a full, okay, so that's 8 bytes, that's as big, or sorry, that's 8 hex digits, that's 32 bits. If this is a 32-bit integer, that's as big as it can get. If we shift by 4, what's going to happen? So these get shifted over by 4. The 1 would fall off, because that's already 32 bits there, and so we just wrap it around. So in the code for this, you have 2 things to do. The first thing you need to do, alright, after you input this number, let's just call this number, let's see, were we told to keep an unsigned int? It's over here. Unsigned int. Okay, so we have an unsigned int x. We read it as a hex number. Okay, first thing we need to do is shift x by, okay, we have this other number, unsigned int b scanf %b address of b. So b is going to be our shift amount. So if we shift it by b, that's the first step. But now we have to worry about things that might fall off the end. There's a variety of ways to do this. In the end, we're going to OR in something for the things that might have fallen off the side. So you can probably, it would be better if you try to figure that out on your own. I'll leave you as that. Okay, so if we shift, if we did 4 here, shifting x by 28 to the right, we'd have the 1 there. So for this example of 4, we shifted 4 bits that way, then we potentially lose those 4 bits, and if you shift x to the right by 28, those bits would be in the right spot to OR them together. Okay, but you need to come up with the expression in general that'll work there. Okay, we'll move on. We've got number 2. The number 2 kind of question from both sample assessments. Number 2 is the one where we are reading a file from standard in, 1 character at a time, and do something with it. Okay, there's no scanf here, there's no arguments. We're reading from standard in, so we need to see what that looks like. I'm just going to put the program up. Okay, this is it. So you want to memorize this kind of thing. There are various ways to do this. We're reading from CIN. We actually could have done this as, let's see, get char goes from standard in. Get C or f get C, read from a file. So if we potentially wanted this to maybe work for another file, do it like this. Okay, so the basic thing here is we do get C, that gives us a character. We save it into the variable called ch, which is an int. If there was a character to read, then we get it. If there's no character, then we get a special symbol called EOF, which is going to be something that can't be saved into a char, which is why we have int here. So if we had char, it won't work right with detecting this EOF, because EOF should be a value that's outside of the character range. That's why we have int being, ch being an int. Okay, so as long as we can get a character, it's not EOF, we do something. In this particular problem, we're counting the number of x's. So you have your way to do a count. Start at 0, add 1 whenever you need to. Alright, that's this type of problem. Okay, then the thing that changes is what are we supposed to do inside the loop? Let's look at number 2 on the second assessment. Okay, so this one, read one character at a time and print letters and white space. Okay, letters and white space. So let's go back to the program we were just looking at, actually. Okay, so we're going to have the same thing, but then inside of here, we need to test if ch is letter or white space. And if it is, then we want to print it. If not, we don't want to print it. So we need to have something about, okay, is it a letter? There's actually a function called isAlpha, which you can use. So if it's a letter, or is it white space? There's a function called isSpace, which you can use. Then we print it. That would be it. If you wanted to do the conditions yourself instead of isAlpha, you could do ch is greater than or equal to a and ch is less or equal to z, or, right, that would be a lowercase letter. You could have a condition for an uppercase letter, and then you need to have a condition for white space, and the white space that you have to check against is, okay, space, but then also /n, new line, /t, tab, /r, carriage return, which shows up in some files. Alright, so if you want to pause, that's taking notes on what the second problem would be like. And that is it for this homework. Good luck if you're still working on that.